All right. Hello, everyone. We are back from lunch. We're going to have our faculty panel. So if everyone could get situated. All right. So the objective of this panel is to highlight the impact and opportunities of AI in science and engineering research and how new faculty can use AI in their research. So we have an amazing panel here. We have our two speakers you met earlier, Sarah Beery and Jay Lee. We have two other speakers you'll be hearing from after this panel, Professor Daniel Forger from mathematics, Professor Yang Chen in statistics, and also my mentor, Professor Venkat Raman from aerospace engineering. So I'm gonna open with several questions and then take questions from the audience before wrapping up. So obviously AI and machine learning is receiving a lot of attention, but what kinds of questions do modern AI tools actually allow us to answer that we previously could not? You want to start with Venkat and work down? I picked you because I know you. So.
So I wanted to I was specifically told to do this. And for us, I think many of the things we do rely on foundational equations, that cannot be solved very easily. So it's not that we don't know the physics per se. So the physics can be written on a piece of paper, but to solve it and get information out of it is much more difficult. So we had to use supercomputers or things like that. So at least in our field, for the way AI has helped is to take massive amounts of data and somehow produce some structure out of it, some kind of reduction. And so, for instance, one of the biggest things we talk about is turbulence that affects, aircrafts and things that are now we design. And it's a very complicated process, and it's not easy to understand. And if you have large-scale simulations, we can extract features or events that happen in the flow, and then we can look at it in an automated way, and from that we can try to see whether we can model it or we can design aircraft different way and so on. So it depends on the kind of field, I would say.
Oh, actually, I have a different perspective because I'm a statistician. The thing that AI time brings to us is more about opportunities, because I got the opportunity to be working with all kinds of data in my graduate school days. I actually was able to discover a really interesting mechanism for protein transportation using our large-scale data analysis. So what we did is that we can use statistical analysis to really disentangle some unobserved process based on observational data. And nowadays, I'm going to give a talk momentarily. So my talk will be about how we use data-driven methods for solar flare predictions to make broader impacts into the scientific community.
Yes, we're going in order, and I'm going to do exactly what you did and try not to give my talk once again in answering the question. But as a mathematician, I think we have a lot of ideas and a lot of algorithms, but the implementation in AI is a whole lot better, and the data sets are just so much bigger. So it really just takes these algorithms and puts them on steroids.
Yeah, I mean, you guys already, I guess, heard my talk, but I guess in the sort of domain of ecology and environmental and biodiversity monitoring, I think a huge benefit of AI is just the scale and speed of data processing. We've already sort of proven that we can process, analyze data at much larger scales and much faster with AI than you can with humans even. And I think what's yet to be seen, but I think has a lot of promise, is applying AI methods to data analysis. So not just, is there a cat in this image, but actually what can you say about the distribution of, that species of cat? And we are making moves in that space, but I think it's still very interesting trying to figure out, where these AI methods perform better or worse than traditional statistical methods. And really, I mean, is AI any different from statistics? I guess that's a broader question. But And I think that one of the things that's very interesting is we end up running into the same challenges that the traditional methods do, which is really when you're scaling up, the biggest issue is evaluation. Can you evaluate something at scale if you don't have data everywhere with like existing labels?
Well, I think do you hear me?
Yeah.
Okay. I think in the morning we talk about the visible and invisible, right? The invisible relationship and how to model. And we know our experience, but we need to model the evidence. So the evidence relate to how the environment, how machine or how human interact. Give example. We have an aerospace professor here. I work with aircraft engine many years, right? Airline. So airline pilot decide how they want to take off, but the weather is very different. So they just take off based on what they think is right. But there's a difference, actually. There's an angle difference. You can save 1% of fuel. Based on every day's, there's a cargo ship in the ocean. There's a wind, wave, right? And they continue to change it, the weather, 3W. But by knowing the relationship, I tune my angle, I can save 6% of fuel a year. So those things we never modeled in engineering world because they're more physics-based, not relationship-based. They're also dynamic changing. You cannot have an engineer in the boat all the time. So that's why data is always there, right? So again, those are invisible opportunities AI can capture, eventually turn into benefits or reduce the risk or to avoid. Yeah, that's what I'm saying.
I think a lot of great points have already been brought up about the challenges and opportunities. It's kind of been touched on in the discussion before. And a lot of you come either from sort of a very AI heavy side and apply to many fields, or the other way. And I was wondering, how do we bridge the gap between domain specialists and AI specialists and find those opportunities that just one or the other might not see?
Oh, wow, okay. I chose really the wrong side of the script. In many, almost every aspect of, I think any engineering you take evolves very similarly. There's a core domain, and then there are ideas outside the domain. And today it's AI, before that could be materials, it could be something else. And which is not, those ideas outside are driven by specialists in those areas, like today it's AI. And they bring their knowledge to this field, or someone from this field goes out and brings that knowledge. And then there's a procedure to integrate them. And initially it proceeds a very similar way that we just take the AI tools, we have data, we just do something, we go look at predict stuff. But over time it evolves and it becomes much more integrated that, the domain specialists have to learn the details of the AI. It's not just a black box they can use, they don't know all the details. And it's that interface where you work on both sides of it. That's where things are interesting, and right now we are at that stage now. So at least in engineering, the notion of neural networks, for instance, I did my undergraduate thesis on artificial neural network, and that was 2 decades ago, so it's a long time ago, right? So things have been evolving over time, and now, most domain researchers sort of understand how neural networks work, and they're able to go in and modify things and change how the whole structure is for their own field. So I think that sort of assimilation of the field itself needs to happen. And that's where we are, I think, at this point.
Oh, based on my collaborative experience, especially in like astronomy and space weather, they have a so-called notion of machine learning amateurs. So essentially they go on the website because there's so much materials online. They learn some sort of neural network architecture and essentially change the data. They don't change any of the hypertuning parameters. They try to run it and get some nice results, and they present it and publish a paper. So in terms of collaboration, many of the things that I actually do is to tell them what to do and what not to do. What are the more principled ways of doing things such that you don't run into something that's like that gives you a mistake or in terms of interpretation of the outcome, or give you an overly optimistic characterization of what's the reality. So from my perspective, a large part of my job is really education. We teach and train the next generation data scientists who could be like domain scientists. They take our courses or talk with us to get the proper skill sets to be trained. They don't have to be a statistician or mathematician. They don't have to have a deep understanding about measure theory or probability, but they have to know what to do about their data sets. So that's part of the thing that I do. And then as a collaborator, I also try to learn the domain knowledges, because you have to speak the same language in order to talk through about what is the actual problem they're trying to solve, instead of anything is a prediction problem. So that's what I do.
So just in terms of background, I'm trained as a mathematical biologist and an applied mathematician. And I think you said so many great things, about educating, about, speaking different languages and so forth. Some of my colleagues might disagree with you about needing to know measure theory, but that's just the way it is. But I mean, I think one very great thing we have at Michigan is a lot of ways where we could form teams or just collaborations well across departments. And MIDAS has actually helped with some of these. And I think just a lot of the collaborations would not have happened, or a lot of the most impactful research I've done wouldn't have happened if we didn't have continual meetings and talks amongst a clinician, a mathematician, and an engineer, and a statistician.
Sorry, in the interest of time, I'll ask the next question at Sarah, and Jay, you can be the first to answer that. It kind of came up on the need for computational power for a lot of these problems. And I think another related problem is the availability or the quality of data. And how do you see this as playing a role in your field, and how do we start to overcome these?
Yeah, I mean, it's definitely true. Like, academia does not have the same capacity or access to infrastructure that industry does. I think that, at least in the fields I work in, the capacity that I have at top tech universities in the US is also massively outstripping the capacity that a land manager in East Africa has. And I think that it actually, for me, it just means that we need to be thinking about these as research directions, pretty fundamental research directions when we think about accessibility and scale and usability of AI, is the efficiency. And that's both data efficiency and computational efficiency. And I brought it up during my talk, but training efficiency. Like, these things need to be more robust to hyperparameters to be able to be kind of, to help people build intuition about how to use them, but also to just make that whole process simpler. And I don't know, I also have like a lot of collaborators, and some of what I do is just trying to teach that intuition around, like, how do you figure out the ways that your model's lying to you, basically. But I just tell everyone to use a ResNet. I'm like, no. I know you saw this fancy architecture. Don't start there. Just use a ResNet, because it's gonna be more robust to hyperparameters, and it's not gonna be worth it to mess around with transformers if you don't have that scale of data. But just like I don't know, the hype is interesting.
Yeah, I mean, I think the computation speed, right, and the cost, and also depend on the scale. We can solve single problems. Probably don't need the HPC, high performance computing, or TensorFlow. Probably don't need it. But when you solve the scalable scale, it's big scale, very fast, right? Speed is very fast, and large number, and then you probably need that kind of different computation. But sometimes we have to find a new novel method to reduce that dimensionality. Okay, for example, some inspection, you're trying to inspect everything. If you have a domain know-how, you probably will train the pattern first. So you only compare the difference. You look at the baseline, so you sort out those kind of difference first, rather to measure everything. So use a novel method to reduce data dimensionality. There's another way to look at it. So sometimes big data is great, but sometimes small data is great too. Depend on how you can use them, sacrifice, balance them. So we work with the Omniverse platform with NVIDIA In fact, they donate to us for $1, right? And because we deal with a large system in industrial systems, and certainly you can vertical build many graphic stuff, and also the knowledge graph eventually become a closed loop training. Yeah, so the different way of learning.
A lot of great points. I'm going to ask one more question before taking questions from the audience. On that note, it also came up in an audience question of this trade-off between complexity and I think an explainability. And I think with AI and tools like PyTorch and deep learning methods, it can be tempting to just throw a neural net at it and this really multi-layered network. And I just wanted to hear your perspectives on the importance of explainability or not going to the most sophisticated method, or what that balance is like.
I haven't thought about this. Actually, also relates to the comment someone made earlier about reviewers asking them to use a neural network and that just for the sake of it. And it didn't make sense. I think in some ways, it's actually better if you actually try a neural network and then you try a simpler method. It is better either way to be able to do that direct comparison and not, instead of saying, why would I use a more complex method if it's just going to be more computationally expensive? Well, you better be able to justify, look, we tried it, it worked just as well, but it was way less efficient. And that's why we chose to use this more efficient method. And the flip side too, like, you better be able to justify that choice to use a neural network, because if a random forest is going to perform just as well or better, then like, why are you doing it? So it actually makes sense. I think we need to not step away from the classic methods because they were classic for a reason, and machine learning is just another tool.
Yeah. I have a different view on this. To me, explainability is a very short-term goal. I think right now we need explainability so we can trust what the machine learned model is doing. And I can imagine 10 or 15 years from now, we may not need this trust. And with that, the notion of explainability goes away. If the machine does not need to convince us that it's doing something right, we won't care about this. So this is like explainability is a way for us to interface our own way of thinking with how the machine is outputting information. So it's a short-term paradigm. I don't think it will last in the longer run.
So you think in 10 years, machine learning is going to be perfect?
Well, I cannot predict the future, otherwise I would believe it. But it's getting there. There are a lot of things that are coming up now. Like even the notion of ChatGPT. I know it's some people think of it like a gimmick, and others think it's the end of the world. It exposes a lot about our own structure of thinking that is very troubling, right? And I think when we say explainability, that's one. I mean, even students writing exams, we ask them to explain their answers, just so that they can communicate with us. That's the whole point. It's not that we don't know the answers, right? So I think explainability is in a way a mode of communication, and maybe it won't be permanent.
But we still ask students to explain their answers, right? So
Because we're training a new generation of students, but
go ahead.
yeah, good.
Yeah, I kind of take a different perspective, but as a mathematical biologist and someone who did an experimental biology postdoc, I think AI and science is driven by these ideas, by these basic principles, physiology, and one needs that. And I mean, the field is just so desperate for it. I remember early on in my career, I would give talks not using machine learning, but using larger models. And I could pick the person out in the audience who would start to get a little antsy and a little upset. And then at a certain point, they'd start to jump out of their seat because they'd say, your model uses 14 parameters. And I could fit an elephant, with 4 parameters and so forth. And, I got so much pressure from the community that I couldn't explain 6 of those parameters. But I think, eventually we might get there, but I think it's not going to be in my lifetime. It's purely a social thing. I mean, I think maybe you're right. Maybe we should just trust machines. But
so your transition has already started, right? At the beginning of this question, you're on the other side, but slowly.
Well, yeah.
the seed of an idea is very hard to take out of your.
No, but I think I just disagree that we're going to not need to have, maybe it doesn't need to be explained, but it needs to be interpretable. And I think that even with something like ChatGPT, like its kind of success is very much built into the fact that it is innately a human in the loop system. You get a response that's not good, you probe it differently. You can sort of start to learn about the way that it works and how to use it effectively for your use case. But I think, and maybe our notion of what that is will change, but I don't think we're ever going to not need to communicate with the systems we build, particularly in high risk areas or something.
Plus also, I think some of these basic intuitive principles or things. I mean, maybe I'm old fashioned and applied mathematicians maybe, but we still believe in Navier-Stokes. I mean, do you think we're just not going to need Navier-Stokes? I mean,
This is a very pertinent question. I don't want to steal the thing, but Andreas is looking at whether it's correct or not. That's part of what he was working on.
yeah.
Yes, I work on fluids. Venkat knows this very well. I do think it's very interesting, this interface between AI and science. But to probe that a little deeper, Venkat, do you think in 10, 20 years, some point in the future, we won't need developers or domain specialists that understand these models and how they're trained? You think we can just shoot some advanced AI at it and we don't need to explain it anymore?
No, I wouldn't think that way. So the way it works is, every field has its own evolution pattern. So I would say like fluids has evolved to a certain state, which is more mature. There are other fields, perhaps for the lack of a better thing, like let's say fusion technology is not at the same level, okay? But I do feel that in the end, they will all evolve to the same level of maturity. And at that point, all fields will be roughly the same. So whether some, and because there are only finite number of humans, we cannot keep expanding our knowledge base. So we had to also accumulate what we know before. And so these machines will start taking over those fields that are very mature, in which perhaps new scientific basis is not necessary or things like that. So I think there's room for both. And I think we will be at a different end of the spectrum than where machines would be.
So one example that I think is an interesting one when you're thinking about the maturity of tools is something like, if you guys are working on flow, like something like finite element analysis, right? And now I think a lot of people have built up the intuition about when this is or is not an effective tool and which scenarios of data it is or is not usable for, and the ways that it might fail. And you've built up so much of this community of knowledge about just how and when to use this tool, that then maybe you don't need as much like probing of it because you feel like you have that knowledge already. And I think that what we will start to see is more people across domains building that intuition about how and when to use AI, and intuition about how it might fail, and being able to match that appropriately to the risks of the actual problems they're working on.
Okay, great discussion. We'll move to questions from the audience. Nathan?
So I just want to follow on from that point that you've just made about having to trust AI, and in 10 years' time, maybe we can just trust it. But Chomsky and some others recently came out of an opinion piece criticizing the chatbots for not having a moral decision-making process. Okay, that's just a chatbot. It's got some morals based on biases in literature that it's been reading. But then in 10 years' time, are you suggesting that we can trust a driverless car to make a decision between running over a group of children or running over an old person, or medical imaging, just taking what the AI bot says as face value and diagnosing based on that without any like input from a domain scientist?
This is a very deep question, okay? So you can always think that even we are only neural networks, yeah? And we've been trained over hundreds of thousands of years. And perhaps one of the ways we express the neural network is through our language. And in a way, our language constrains our thinking also, which is why people thinking in different, like if you think with math, you think differently than you think with English, right? Maybe ChatGPT or these transformers, they're trying to abstract that concept of learning a language to learn our intrinsic neural network. Now, if that's the case, if language represents all we know, then this is all we need, right? And we don't know that the answer to that, we don't know. But I think morality is a very different thing. I think that's 1,000 years ago, our morality was vastly different than what it is now. So maybe, the value we assign to individuals, the value we assign to different objects, they change with time. So it's hard to, I was just having a discussion with my kid yesterday. Like we have a robot that vacuums the floor. If that robot would talk to you, would you be more respectful of it? But now it's not talking to you, it's just rolling around, and then she wants to kick it out because it's bothering her. So there are things like this.
Yeah, I want a talking robot machine to clean my floor. But what I want to say is that it's hard to change people's moral habits, but technology has shown. For example, a few weeks ago, we have a department seminar that a speaker from Stanford already showed that in terms of initial diagnosis of skin cancer, like a totally machine learning based method is beating hospital doctors in terms of the initial assessments. The accuracy is just very, very different. And these kind of things is definitely gonna be in use in the near future. I would say not even taking 10 years. It's gonna be in the near future. But then do people trust it? If a doctor tells you your kid has skin cancer based on the machine, and then you'll be like, no, I'm not going to trust it because it's not a doctor. So I think human will be still aiding that procedure, but a lot of the parts will be replaced by the machine, in my opinion.
One of the things that we've found is that often the machine learning models are more reliable than humans for environmental data processing, but it's not because they're more accurate, it's because they don't get tired. It's like, people who are counting birds from the air, like flying over and trying to count birds. You can actually explicitly study how, like, from the beginning to the end of the survey, they get worse at it. And so maybe the machine learning model is like a little less accurate, but it's like sort of can continue to pay the same amount of attention. And I think that they've seen the same thing with doctors, where it's like the amount of attention they're paying actually really changes their prognosis. So exactly.
So if I could just add a quick plug, we just set up a Muri here, which I'm running, thinking about fatigue. And machine has a lot of machine learning. So I think what's going to end up happening is that these people are going to have some sort of feedback as to how fatigued they are, which will allow them to do better predictions.
That's cool.
Thank you.
Yutong? Yeah, Yutong.
So given that today a lot of us are working in AI plus something else, and also that there are domain-specific journals and conferences, but also CS conferences that are kind of very competitive. What do you think are the roles for, like, how do we decide where to publish, and what are the roles that these conferences play, and what does that mean for our research, and in terms of like how well received it is and things like that, just in general? What are our thoughts on like how conferences research, AI research should be organized?
Great question. So maybe we can start with Jay.
Well, it's a different type of answer. Well, I think certainly we learn, we know what we know, we don't know what we don't know, right? So AI is not about to solve problems, and really to look at how to create potential that we should be think about more, right? And so I think it's good to expand. I think this is a good, what you have is good. You expand engineering, biology, social science, much broader, which is a good way, because that gives people a good stimulation about what thing you should think about, right? So AI learning is not about technology itself. Just like a medical, it's not just about diagnostics. It's about the care. You want to see doctor because they care about you. They care about you, which is a big thing. Just give you results, a big deal. But care is what patient feel the most. Encourage. So what I'm saying is AI is a lot of things we learn, because we have to predict, prevent, even to avoid things, right? So it's not about solve problems. Yeah, I think it's a good interdisciplinary, multicultural kind of learning. Yeah.
Yeah. So we spent about maybe 30 minutes over lunch talking about choices in publication venue and kind of these different factors. And I think probably part of it is just thinking about what community you want to be communicating the research to. And then you basically have to choose where you're going to publish it. And then you have to think about how you're going to communicate and sort of make sure that it is visible on the other side, because we don't yet have so many opportunities to really publish in high impact ways in the middle. There is now a Journal of Environmental Data Science, for example, but it's quite nascent. It's about 1.5 years old, like to be determined how well those things work. And we were also talking about these fundamental differences just in the structures of publishing in conferences versus journals, and kind of like the peer review process. And like, yes, the computer vision and machine learning conferences are incredibly competitive, and the review process is almost random. Like they did that explicit study at NeurIPS where they took like, I think 10 papers and had them reviewed by different panels, and they got less than random agreement on what should be accepted. So you just take all that with a grain of salt, but it also depends on what career you want. And I do know that, you know, if you're looking for CS faculty jobs, it's not impossible, but they are going to look for CS publication venues. And if you're looking for faculty jobs in these other areas, I mean, I had ecology departments be like, well, she doesn't have any papers. Like this girl's like never published a paper, because all my papers were at CVPR, and they thought that that wasn't a real paper. So.
So, a couple of thoughts. So my version of that story was I did a bio postdoc. Those applied mathematicians know the big applied math organization is SIAM. And when I went on the job market, they set up a meeting for me. The most famous person in the department, National Academy member, was going through my CV. And he was telling me biologists give you 3 points for science, nature, and cell, you know, 2 points for neuron, whatever. And then he's going through adding up, and we got to like 10. And then he said 9. And I said, you went down 1. I can't lose credit. He's like, you have a paper, Siam Journal of Applied Math. Isn't Siam like a country in Asia or something? You know, these are the kinds of crazy comments you're going to get, which highlights, you know, just how difficult it is to be an interdisciplinary person. Along with that, I tried early in most of the papers I publish typically have new data, new theory, and, you know, new scientific results. That's what I really try for. And early on, I had some beautiful papers that I absolutely loved that had all that did terrible in peer review. And the answer is there's no reader out there who really is going to understand the full data and the math theory and the science of it. So, and just one piece of advice I would have is when you do write your papers, always have that audience in mind. And if that audience really is machine learning, send it to one of these conferences. If that audience really is the science, and sometimes you split, so some of those papers that couldn't get in anywhere, I split into 2 papers, gave them half, and they did very well.
Yeah.
So,
I think that point about audiences, like we have a lot of papers that we could easily submit to Methods in Ecology and Evolution or to CVPR, right? And you make that choice based on the student, their career goals, the people you want to read it, but you also then write a different paper. Like the methods are the same, but the way that you write the paper is fundamentally different. And part of what I think all of us need to learn to do is how do you write the papers for these different venues? And that's annoying because most people only have to learn how to write the papers for one discipline. You have to kind of learn how to do it in multiple directions.
Maybe we'll take one more audience question, if there are any. So sort of building off of that, how do, in your experience, you start these collaborations and interdisciplinary work, and how do you, in that also, not get lost in the domain specialist that you're sort of new to, or the other way with the AI specialist where you're bringing certain domain knowledge?
What do you mean get lost?
As in, if you're an AI researcher going into a totally new field, how do you still make that work your own and have a significant impact in that?
I'll take a shot. I think it is a difficult task. So I have to say this, this program, the Schmidt AI Fellows program, tries to address essentially that principal question, right? And so many of you I know from the introductory workshop come from different fields, not from AI fields, but from the different disciplines. And it is difficult to go to the AI field and then make a mark there, starting from there. I think that's a transition that has happened over maybe few years. I think the initial impact will be in the disciplines. And then you slowly learn, okay, I have to really change AI itself if I have to make a bigger impact in my discipline, and you learn more. But I think, starting from where you're most comfortable with makes the most sense, given the short time frames also.
Yeah, I can add something. I think the one thing we found is a fear versus comfort zone. If you're a pure AI scientist, you tend to push the stream case. It's a high, huge data. You want a deep learning. You want everything extreme, right? But it's not true because, for example, I teach industrial AI course. All the students have to solve the problem in EV, battery, semiconductor, jet engines, healthcare, all different kinds. Once they've done the homework, they share, you know what? They gain greater confidence. Wow, I can solve jet engine problem. I don't even believe myself. It's just features. I tell you, this is the altitude, this is the Mach speed, this is the how, oh, okay, I got it. It's very quickly to adapt to it. You're not expert, but you understand the domain, right? Then you select feature differently. So I'm saying, I think it's using a different domain, give you the confidence, reduce the fear. Because eventually, if you have a hammer in your hand, you tend to find the nails, right? But probably in the real world, another way around. You need a solution, you need a purpose first. Go back to fix your problems. So I think it depends on how you want to train engineers, of course, right? I think it's very important to understand the comfort zone versus a fear. Yeah.
I also think that there's maybe a dangerous place to fall into, which is like this very like tech savory thing where you're like, there's a really hard problem in this other field. Like, don't fear, I have the power of machine learning. Like I will solve all of your problems. And I think one of the things that I really think is incredibly valuable is not trying to do everything end to end yourself, but seeking out the right collaborators that are going to meet you in the middle. If I'm a slightly more computer vision flavored researcher, that's more of my wheelhouse. I'll work very directly with people who are experts in species distribution modeling, and we'll try to jointly build both problems and solutions. And I really like to work that way. I think you both learn. And I think it does give you this much more nuanced understanding, and you're much less likely to fall down a hole of like, just throw me your data over the wall and I'll solve all your problems, which is like, I think just doesn't actually ever work out.
Great, thank you for all that. I think to round out, we'll have one last question, just sort of a reaching speculative question. In 20 years' time or further, how do you see AI changing the way research is performed, given that already with ChatGPT and all these major successes, I think the landscape is shifting very quickly? We'll start in the middle with Daniel.
Well, I will say I felt a certain luxury being in a math department. My wife teaches in the humanities here at Michigan. And when ChatGPT came around, I know a lot of the humanities faculty were really very worried. Not like the stellar essay, but, some of those others, how they do it. So, I mean, I don't have any specific information. I do know that people are using ChatGPT to search the literature more easily now. I think it'll also change, teaching. Elsevier, I saw, came up with a new policy that allows you to use ChatGPT to like edit your papers, but you need to declare it. I think it, but I do think that there always will be, and this is where I think it's interesting to have this debate. I'm a believer in the individual scientist who's going to have this life-changing idea, and I sincerely hope that that will continue to happen for a very long time. I think I'd be a lot more excited about my life if I went into the office every day, and just read off printouts from a computer and say, oh, this is even better than what I would have thought of. But then again, maybe I could play golf or go fishing.
I think the real success stories that we've often seen with AI is when they're able to make humanity efficient, right? It's like when now AI is somehow partnering with a human to enable them to do something faster, to scale up. I mean, when you're talking about the editing of papers, like, I think that it's amazing to think about how we could reduce some of those really nasty language biases and like English as a first language speaker biases in our publication track record. So that's really the scientific ideas, not like how good your grammar is, that are speaking to your papers. And I think that there's some really amazing and exciting benefits there. But at least for me, I mean, I would love it if we could make it so that any ecologist could say, oh, okay, like, here's this interesting hypothesis I have. Now, how do I test this hypothesis given all of the data that's been collected throughout history of the world, and like just querying those systems in this interactive and like useful way? I mean, like, I can totally imagine that it changes the way we do science, but I don't see it no longer having a human or a scientist play a role at all.
Yeah, I totally agree with that. I think in the future, we'll spend more time on the innovation part instead of a lot of the tedious job that we do as a scientist, like looking up for literature and trying to produce some numbers and trying to show some preliminary analysis. And I'm also looking forward to embrace this for the education part of my job, which hopefully I don't have to do any grading in the future. No debugging for the students.
Or you're going to be more efficient at grading.
I like that.
Yeah, well, for me, right, I think during lunch we talked about our goal is to make AI happen one day, 1 hour, right? Not 10 years, eventually soon. And if you realistically, I want to make a 10x improvements in speed, make a mistake faster, learn things faster, 10x, right? Human beings are not just to do the right things. Sometimes I know what things don't have to do. They're even better. If you try 10 different options, you waste time. If you know 9 options out, then you can focus. So I think for me, it's a 10x improvements in learning, in making mistakes, speed, and also in developing AI. That's what I'm doing anyway. Yeah.
Okay, I'll have a completely different view, just for the sake of it. So I was watching Neil deGrasse Tyson. I'm sure many of you are familiar with him. And he said something that was very profound. I never thought of this, and maybe I'm quoting it completely wrong. But if you look at the DNA of a chimpanzee and then compare to DNA of humans, there's not a huge difference. It's a very small difference. And the way we think about the planet, how we structure it, is so different from these two species. Right? So it takes very little to really push things far out. So I feel that we are getting to a point where these machines, like, either learning fast, making mistakes faster, things like that, they can have that 1 or 2% improvement over humans. And if it does, then the world is vastly different from what we can imagine today. Mm-hmm. And we don't know how it will be, right? And whether it's good or bad, we don't know. But the potential exists, and that to me is the most valuable part of this. And these things will all maybe happen because of the research that you guys do.
If I can make
Yeah.
about that, which is over Christmas, my wife bought me a book about prediction from a bunch of the CDL people. And one of the key things that it's arguing is that, so I think we may get to that 1% improvement, but there's so much work to change the system, that, and the processes, and the factories, and the business models, and so forth, that we may in theory have that, but I don't necessarily see the world changing just because it's so hard to, there may be enlightened people on boards and things who could start pushing us in that way, but it's they make the argument about, the internet, taking so long from when it was, and I think we're going to see the same thing with AI soon, maybe in 50 years.
But I think we do see, right, like, it's like the areas where implementing and using AI are already, like, the infrastructure already exists because the internet already exists. Those are the areas like ChatGPT, chatbots is one of these, or like, programming and having like a Copilot. Like, there are areas where you don't have to build infrastructure and it is already making a big difference. And I completely agree with you that, like, the areas where we need to build out and change systems and change funding structures and like all of this stuff, it will take a lot longer.
All right, on that note, I'd like to thank the panel and thank you.